Is it time? Is it time yet?
It is time.
So thank you for spending your last session of the day with me. I know you're all eager to go to the party tonight. But I'm going to ask you to do one thing for me. Not this one. I'm into taking little videos around NIWeek. So I'm going to ask you to all stand up. And on the count of three, I'm going to ask you to say, to yell out, scream out, "We love LabVIEW." Ready? 1, 2, 3.
We love LabVIEW.
Yeah.
Oh. Thank you. Now you're on the Twitters, whether you like it or not. Okay.
That'll be $10. I charge by the minute.
So thank you. Basically, this presentation is going to focus on the new event features in LabVIEW 2013. So if you don't care about those, then you're in the wrong room. There was some description in the session notes saying that we're going to present the JKI state machine 2.0 perhaps. If we have time, I'll show you that at the end. But there's a lot of material to cover, so I'm just going to go right through it. Before I get to the presentation, I just want to tell you a little story. I posted this on Lava. I'm into memes and internet stuff, so you're going to see a lot of weird things in this presentation. But anybody familiar with the overly attached girlfriend and all meme? Okay. Mm-hmm. So I posted this on Lava. I want to learn language so I can come to NIWeek with you. And I posted that about in January, and I had no idea I was going to go to VidCon this weekend. So it happened to be that the overly attached girlfriend was there. So I said, I got to take a picture with you. And I put a little bubble there. Unfortunately, she didn't come to NIWeek, so.
Oh.
Making the most of new features, of the new event features in LabVIEW 2013. So one disclaimer is I don't work for NI, so I don't have all the answers. We have people from NI here in the audience that could answer some maybe advanced questions that I may not be able to answer. So I didn't develop this feature, so don't blame me for anything. I tried the features in the beta, and I'm familiar with how they work. I've consulted with some NI engineers about the features, so I'm pretty familiar with it, but I'm not an expert by no means. Sorry for a second here. There has to be one more thing. That's what we call a presentation. Sorry about that. I want to ask a question of the audience. Who here programs with user events in LabVIEW? Okay, so a lot of you, so I guess that's why you're here. Are there some of you that still don't use events or user events because you're maybe afraid of them or you're not sure, or, oh, awesome. So everyone loves user events. Does anybody here have an inter-process framework that uses user events as the core communication method? Okay, several of you. Okay. What would you say for those that don't would be one of the limiting factors for you not using user events as your communication method.
Ability to see any stacked up events with queue plus it.
Okay, you don't have the ability to see what's in the queue. There's a queue? I didn't know there was a queue. Okay, any other issues, perhaps?
Well, at least before 2013, I don't know, but sometimes if you had multiple events registered, it wouldn't. Well, sometimes it wouldn't. They talked about this last session with the Jack.
So if you have multiple events coming in really fast, you can't process them fast enough, perhaps?
No, if you had multiple event statements, sometimes they won't catch it, depending on how you register for them.
Okay, some
They won't
events
both.
wouldn't get captured depending on how you register.
Yeah.
Okay. Probably need a little bit more explanation on that one because I wasn't at the previous session, so I'm not sure
Okay.
what you mean. But maybe you can come later and then we can
Sure,
talk about it.
So prioritizing.
Prioritizing events, well, we don't have any prioritization capabilities, right? Okay. So before I get into the features, I know you're all eager to find out what these cool new features are. I just want to pull back the curtain a little bit on events, see who the man behind the curtain is. And I'm going to quickly go through this because it looks like everyone in the audience is pretty experienced with user events, but we'll do a quick refresher here. When you're registering for dynamic events, you do it on the outside of the event structure, right, before you hit the event structure. And that's how you create a user event, right? And you can also dynamically register for control events on the front panel if you wanted to. And you can also statically register for events. And statically registering means you pop up on the event editor dialog and you configure your events that way. That's static registration. The reason we call that dynamic is you can programmatically control when you register and you can unregister for events as well. And of course, you need an event structure to handle the events. Without the event structure, you basically have events that are not being handled by anyone. So when you actually do a dynamic event registration, what happens is you're actually, behind the scenes, there's some magic happens, and actually a queue gets created, right? And also when you statically register for events, a queue gets created as well. And so now we have two queues that we have to worry about. And both of these queues get handled by the event structure. So the event structure basically, when you wire this event registration ref num to the event structure, you're basically telling the event structure that here's your dynamic events, and it already knows about the static events. And then when it executes, hopefully in a loop, it'll go through and handle all the events that come through from any of the queues. In this situation, what I'm showing is that you actually have still two queues that get created, even though it's the same user event and the same control. What happens is two separate queues get created, so that way, when an event gets fired, a copy of the event is sent to both event structures, so they can be handled separately. Everybody okay with that so far? So what happens in this scenario? Well, what we're seeing is that in the top event structure, we have two dynamic event registrations which are bundled together. And then we wire that whole cluster to the event structure. But behind the scenes, LabVIEW creates actually two separate queues, two dynamic queues. And I guess you're asking, well, why would we do that? Basically for organization, on the diagram you can actually control a little bit better your dynamic registrations. For example, if you want to unregister, here we only have one or two elements that we're registering, but if we have dozens of them, we might want to group them separately and manage them in different parts of our code. So for organization's sake, you might want to do that. Let's get to the meat of it. New event features in LabVIEW 2013. Now, the reason why we came back to talking about queues is we want to make sure that everyone is familiar that behind the scenes there's queues, because a lot of the new features manipulate the queue. So it's good to know how the queues work behind the scenes. And I'll start off with the event inspector window. So the event inspector window is a brand new feature in LabVIEW 2013. It's a dialog. It's a non-modal dialog that shows up, and that's how it looks like. And the best way to see how it works is to go through a demo. So here we have a simple VI. Try to keep it simple to sort of get these concepts across. And at the top we have what I showed in my slide, which is 2 dynamic event registrations, an event structure, which is handling all the events. And at the bottom I have I have a while loop with buttons that you can fire different events. So if I right-click to access the event inspector window, I right-click on the event structure and say event inspector window. I should say go inspector gadget. Anyway. So as you see here, nothing shows up. That's because there are no VIs running or reserved for execution that actually have an event structure on the diagram. But once we run the VI, you'll see that we have a bunch of events that are flowing through. And these events are timeout events. Okay? Because here on this event structure, we've set a timeout of 100 milliseconds. There's a cool feature in the inspector window where you could turn those off, because it's pretty noisy, so we'll turn that off. And we'll clear this list. So let's look at the main components of this window. First of all, we have the selector at the top, which allows you to select between different active VIs. And you can scroll through that. The main table contains several important components or data elements of the events. Start from the left, there's a sequence number. This is new in LabVIEW 2013. Now, behind the scenes, there's actually a sequence number that gets assigned to every event. It's a unique sequence number. There's the QID. Actually, let me just fire off a few events so that it looks better. Okay. And put some slider stuff in there. And as you saw, as I was clicking the events, they were popping up on that table at the top, but they're immediately going away. That's because they were immediately being serviced, right? They're being handled. But if you had a backlog of events, you'd see the list growing and growing and growing, and that would be the list that would be your queue. That's or multiple queues actually, because they're all summarized in one table of all the events that are ready to be handled. Okay. Now below is a log of the history of what's happened in the past, and each element in the log corresponds to the same titles up there in the table. So on the left we have a sequence number. QID is basically an ID number for the queues that are behind the scenes. So here in this case, QID is showing as 9, 10, and if I hit the stop button, you'll see that there's one more QID 2. Basically, the stop is a static event, so the QID of the static queue is 2. So that's why it shows up as 2 there. So remember, behind the scenes, there's two dynamic queues and 1 static queue at the top there. Then we have the time for the event, what time the event got fired. Then we have the event reference, and that would be the same as if you would, for example, probe this wire here. So if you would probe that, you would see the same number on there as you would in this list. Here it's giving you the event type, so it's user events or value change of the slider. Now you'll notice something different on this event. It says unhandled. So I've done something different behind the scenes here, which I haven't explained, is that even though I have two dynamic registrations, I only have a case to handle the one user event. The other user event I have not created a case for. So when you look at this list, the events still get fired, but they show up here as unhandled, which is good to know because that's kind of a warning to you saying you have an unhandled. You have events that are unhandled. Are you sure you want that? And if that's okay, you can just ignore this indication here. Any questions so far?
Yeah, just so why didn't they stay in the unhandled event initially? They didn't stay there. I thought they would be, if they don't get handled, I thought the list would get filled of unhandled events.
Events still get fired, and they go nowhere.
So they still
There's no one to handle.
When the event structure executes, it always takes the next available event. If that event doesn't have a case, then it discards it and goes back to sleep.
So
that's
it
what
discards
it
the event and goes back to sleep.
It discards it. Okay.
Does the event inspector also show events from X controls?
From X control.
Yes.
Yes. This is all cool stuff. I'm still learning it myself, so I'm really excited about these features. It's really awesome. Okay, so that's it for that.
Another question.
Another question?
Well, as you can not look at events from the timeout, can you avoid looking at events from other VIs or from the X controls?
So here in this list is the list of what you're looking at. So you basically can only look at one VI at a time. So here I only have one open and running, but here if I had more, I would see the whole list of all my stuff, and then I can select which one I want to see at that time.
So if there are X controls in that VI, you can still see those.
I assume they would. I don't know yet.
They would show up in another list in that ring.
Okay.
Events are still logged even when you're not looking at them. So if you switch to the ring, you'll see events that happen when you weren't looking.
So this log shows events of whatever VI you're looking at. So if you switch to a different VI, it would show the log of the other VI. Oops. Okay. So that's the event inspector window. And the reason why I'm mentioning it first is because we're going to be using that to sort of show you some of the other features that I'm going to be presenting as well. The next feature I'd like to talk about is high priority events. And that's how you send a cat high priority mail. All you have to do is type in what you want to look for and just put cat at the end of it. Okay, so generate user event function has a new input. It's called priority. And you get two priorities. You get high priority and normal priority. So it's an enum. It's an enum with the two values. If you specify a high priority, then what happens is it goes in front of the normal priority events. And as you can see in this graphic, we have a dynamic event queue and a static event queue. And the event structure basically handles both queues at once, depending on the sequence number. And if you have a high priority event, basically they get placed in front of the normal priority events, in front of a normal priority dynamic events and normal priority static events as well. However, if you fire off multiple high priority events, they still get treated within within all the high priority. They still get treated in sequence based on sequence number and the time they came in. And that's how they're processed as well. So we have basically two levels of priority: normal and high. Okay. So I was trying to use Christina's bookmarks tool to navigate my examples. Let's see if that works here. Okay. So in this example, we have the event structure at the top here, and we have a firing of an event which actually generates a waveform of data. Okay, with multiple points very quickly in quick succession. So let's see what happens here. So if we run this, you'll see the events. If I hit the stop button, nothing happens. So it ignores the stop. And if we look at the event structure here, this is the data that comes in from this user event. And these user events are being fired at normal priority. And the chart displays the waveform. And there's a small delay in here of 100 milliseconds. So basically, my consumer loop, my event structure, is processing the events at that 100 millisecond rate. The reason why I have a delay is to simulate that there's some work involved in there. That could be some code that's processing the data coming in. Now, while it's in here processing this event, if I hit the stop button, which is down here, the stop event is over here, which stops the loop. It stops all the loops actually. It'll get put to the end of the queue. So it needs to process all that data first before it can get to the stop button. So what we can do now here on the stop is we can switch it to high priority. Reset that. So now if I fire my waveform, I hit stop, it stops right away. Because that's treated as a high priority event, it gets handled, it gets put to the front. That's awesome, right? Okay. So now if you have these processes that are consuming data and you want to basically stop them all immediately and you're using an event structure, you can use high priority events to handle them. Also, high priority events, as I mentioned, interrupt static event registration. So here we have the slider, which is statically registered. It also has a delay. If I run that and just move the slider up and down, I'm letting go and it's still processing. Let's add a few more in there. And I hit stop, and it aborts it right away. Again, that's a situation where you have, it's a common problem. I see it on the forums all the time. I have a slider and it's bombarding me with data. How do I interrupt it, or how do I put stuff in front of it? So that's how you can do that. There's another feature I'll be talking about which also handles the ability to control that flow of data as well. Any questions so far? That's a good question. So let's go to demo 2. So if you look at this event inspector window, you can actually see what's going on behind the scenes. So you have the value chain of the slider. You see it says user event came in, high priority, and it basically, the rest after this, it just got rid of all the data and it shows as flushed. So it discarded all the events after that. Okay.
So you can't change priority of static events. You can't.
No, you cannot.
You also can have static user, it's a user event.
You cannot set a priority on statically registered events, and you can't set priority on static or controls that are dynamically registered. Yeah.
It's user events that are high priority. It's not.
Exactly. It's mainly user events that this feature applies to.
Good question. So that would be one benefit of dynamically registering the user sort of panel control, because you could assign a priority to it without otherwise with a static registration. You just said that with a static registration with a user control, a front panel control, you can't have priority assigned.
No.
But if you assign a user event outside of the loop to a change in value to that control, then you could assign priority to that. example which demonstrated here.
Yeah, I mean, if you had, if you're converting the control to a user event message, yeah, I mean, you could do that.
That's exactly what you're doing in the bottom.
Yeah, right.
It's important to note that the high priority is not associated with the slider value change. It's because he created a user event that the value change fires, or that is fired when it stop.
Yeah, basically.
Automatically creating a user event that's high priority. It's not the slider value change or the stop button have high priority itself. High priority is not associated with controls at all.
Yeah. So just to clarify, high priority is not associated with controls. It's not a static event feature. It's only for user events. And it's not a priority on the stop button itself. It's the user event that got fired as a high priority. Yeah, just to clarify that. Yes.
Just a simple question. How in the program you determine which of this structure is firing through the there's not that many three of them there. I can tell which one is firing and what's active.
Oh, here, yeah. You want to figure out in this list to what event structure applies to?
Yeah.
Well, that's a good question. I would consult with NI, give them some feedback. But anyway, there's a queue ID, as I mentioned, which actually is what you really want, because you want to know what queue you're working with. So
You associate that with something. I didn't know what 10 means. Which 11, 12.
I don't know how to associate the queue ID to a specific one at this point. You'd have to experiment because, for example, you can tell that the slider is 10, which is a static. So now you know that the static is 10 because you see the event related to a specific control, because that's how you can match it. That's one way to do it.
Does the QID change
It'll,
when you run?
if you want to be able to run again, and you get more queues. The queues are assigned when the VI is present run, and the static event structure queues will always have lower numbers than the dynamic ones.
Static event QIDs are lower numbers than dynamic, and basically those numbers are assigned when the VI is reserved for execution or it's started running. Any other questions? Yep.
Is it possible from within the code and get the number of elements in the queue, like in a normal queue, you can hold the queue and see how many elements there are?
No. That's what the event inspector window is for, to tell you basically what's in the queue in that top list.
When I build a program, I would like to have sort of a better handling mechanism that if I have an event trace somewhere, it can start pressing the queue or give a warning that there's some issue.
As far as I know, currently there's no programmatic way to inspect the queue. It's only through this dialog. So there's people from the listening. So. Okay. Now another problem that a lot of people who are using user events come across is that there's a lot of events that are coming in rapid succession, and they want some way to throttle that or flush the queue, right? And the reason why I have this picture up is because, you know, I'm a fan of The Walking Dead. I don't know if anybody else is here, but if you come across a horde of zombies, I mean, you're done. I mean, you can't fend them off. But if it's like 1 or 2 zombies, you can just kill them one at a time. You know, it's pretty cool. But if there's a whole bunch of them come at you all at once, then you're swamped, right? So that you can't do anything about it. So you want a way to be able to flush all those zombies away or flush the event queue function. And NI has provided us with the ability to do that now. There's a new function called flush event queue. And it's located on the palette, right in the events palette, obviously. And that's the counter pane of that. And I'll just let you soak that in a little bit. And it only works on notify events. So that's an important thing to note. And so if you have a combination of notify and filter events, and you're flushing, it'll only flush all the notify events up to the first filter event. Okay, that's an important point. Now, one thing that you need to focus on here is the event registration ref num, and that's very important. So you need that event registration ref num if you're working on the dynamic, in order to flush the dynamic event queue, right? So it needs to know what queue you're working on, and that's one way it can figure it out. However, this function is super smart and all-knowing. So if you drop it inside of an event structure, you don't actually have to wire that event registration ref num. And if you do not wire it, then you're basically signaling to that function that you're going to be flushing the static event queue only. Okay? Because it has no knowledge of the dynamic event queue because you don't have that wired in. Just a second. And when you have, so you can have it inside an event structure. You can have the event registration from unwired or wired if you need to. So both ways it works. But you can also have it outside of the event structure. So in a parallel loop, if you want to do some throttling and controlling things, you can put it in a parallel loop. Or you can send that ref num to another VI and do something in parallel if you want to be able to flush the queue on certain conditions. So you can do that as well. So that ref num works either wired or unwired. Yes, what's your question? That's the ability to control what's flushed was the question. Yes, you can control what's flushed, and it's an interesting way that it's been implemented because it's all using the LabVIEW paradigm here. So basically, you can wire into the event type or object input. You can wire event types. So you can wire a single event type, an array of event types. You can wire a cluster of event types if you're a cluster kind of person. And then it'll actually only flush those event types. So you can fine tune it to that. But not only that, you can flush them by object type as well. So if you have object references going in, it'll only operate on those object types. And yes, if you wire a user event object reference, then it'll only flush that user event. So you can filter basically what you want to flush. Or you can do both. It's all the same terminal. Isn't that awesome? Some people would maybe think not, but it's pretty cool that it can do that. Actually, I haven't tried any other combinations. Are there any other things that it can do? But that's pretty much it, right? So if you combine in a cluster like this, the event types and the object. So basically, what you're telling LabVIEW here is, okay, of this Boolean, there may be other event types that are coming through, but I only want you to flush the value changes in the mouse down. And everything else from this Boolean can go through. The same here. This is on the pane, mouse enter, mouse leave, that type of thing. So you're giving, this is basically like giving commands to this function as to what you want to flush.
A question?
Yes.
Maybe I missed something. So this is selective by types, but not by specific user event ref num.
You can
do that as well?
you can wire in a user event ref num. Yes, you can.
Those controls are specific controls. So those are bound control references you show. So those are events on particular controls.
It's not really by object type, it's more by object by reference. It's not flushing all events sourced from a numeric or any kind.
No, it's not of any kind. It's that specific
Right.
one.
And I actually thought about supporting wiring a not a reference value of a certain type to be a wildcard, but it was already complicated enough, so I did not.
So the comment from Craig here was that he was considering putting a not a reference type in there where you can wire like a filter a wildcard of like all booleans or something like that, but he considered that it was too complicated. So this is all documented quite nicely actually in the LabVIEW hub. So that's pretty cool. You can also wire things like LabVIEW VI server object references, so you can put those things as well. Basically, anything that you can dynamically register, you can wire in there as as a filter to tell it, filter these things out. Okay, so we talked about how you can flush by event type or object type, or specific object, I guess. Now there's another input called oldest event time, and it gives you even more control of the filtering process, and it's in milliseconds, and this is the time where you want to start keeping events. So basically, if you specify a time value there, every event has a timestamp on it, and these are the oldest events, those are the newest events. So if you specify a specific time, then it'll basically discard, or it'll flush all these events. And so you might want to say, well, if certain events are coming in that are older than a certain time, then discard them. Any questions on that? Yep.
So that flush is a queue function,
It's the same function all this time, yeah.
and it's only for notify.
For notify events only, yeah.
I think we have another question.
There's another.
Yep.
So by pulling out that, I guess, timestamp, there's no way for you to maybe insert it elsewhere and say, well, actually, I'd like you to flip space spots with this event, or this, yeah.
Well, what are you asking? You want to swap events?
Well, just by using those stamps right there would make sense. Well, hey, look for this one and swap with this, or not? Am I thinking?
I'm not sure what you might
ridiculous
swap it.
I'm not sure what you would use that
It's
for.
just inserted as it.
Yeah. You
Delete
can't
everything
swap
over.
things. I guess that's the answer.
You can, yeah.
Well, I'm just asking, instead of saying high priority, throw it to the front, just put it 2 spots, in front of this other one. Like you don't want it all the way in front, but.
No, you're talking about high priority events. I mean, you can.
Let's see.
This is a flush action. And basically, this is stuff in the queue. You're basically throwing stuff out of the queue. This is not related to high priority. Is basically a user event you fire. You set it high priority. It just puts it to the front of the normal priority. And after.
I was saying instead of saying high priority, throw it to the front. Just say, put it 2 events. Assuming you got backed up 100 events and you would like it at event 50 instead.
There's no control of to where to put the high priority. Yeah, you have no control over that. Yeah.
Question.
Yes.
But your events aren't really in time order if you've got high priority and normal, right? Because they might, ones at the top might be older. Or, high priority ones.
Okay, that's a good question. Basically, did you hear the question?
It's when they come in anyway. It's when they come in anyway. Must be more.
It basically goes from the back of the event queue and goes forward until it finds that it more than that, and it stops. So that's the way it works.
Okay. It goes from the back of the queue forward until it finds
From the front.
From the front, yeah.
Oldest events.
from the oldest, yeah, until it finds events of that time.
So the high priority events would be good
So high priority
deleted.
events would not get flushed unless they were already older than that time. They weren't over before.
So
Right.
it's basically time based. So even if you have high priority events, it starts from the high priority events, obviously because they're at the front, and it goes through until it hits that time, and then it operates on that.
So you could lose newer low priority events. Because they're in the queue behind the high priority events, right? If you flush everything back.
Yeah.
Just like
It'll stop as soon as it finds something that's new enough. What that means is, if you have new normal priority events, it won't flush any of your high priority events. But if you don't have any new low priority events, it may flush some of your high priority events.
No, it starts at the high priority, not the low priority, right?
No, it starts at
Well, I don't
low
know.
priority back. So, based on whether you have
Good point.
new normal priority events, you may or may not flush any of your high priority events.
Okay.
Even for
Clear as mud, right? it's one of those features. This is a feature that the community still needs to sort of dig their teeth into and work on and hash out all the issues on the forums and everywhere, and really understand how it works, because it's a difficult concept sometimes to wrap your head around, because there's just so many options on this function, and if you have them all wired up, it's like, okay, what do I have going on here? As I said, there's multiple inputs on this. So there's another input called keep most recent, and all events older than in this example, the 5 most recent total are discarded. The reason why I say total is because there's the static and the dynamic, and so a combination of all the events that are in all the queues, the 5 of all, a total of 5 from all the queues that are being processed on that event structure. And for this one, it works together with that type input as well. So it'll keep the 5 most recent of that specific type that you wired. This is an example of value change, but you can have all the other combinations I mentioned earlier. You can also have a combination of this of this input to keep most recent, but you can also have wired the oldest time input as well. So you can have both of them combined as well.
So then it's an OR, basically.
It's an OR operation.
It's either the 5 most recent or it's new the timestamp steps.
Yeah, it's an OR operation between the time and the 5 most recent. Any other questions on the flush and all these magical inputs? Okay. There are no examples in LabVIEW 2013, unfortunately, related to this. So we're going to have to make up our own as a community. Okay. I think this is the last input, yes. Include static events. So what does this tell you? Well, basically, it's basically what it says. If you have that set to a certain value, you can either flush, in your flush operation, you can include static events or not, and then it will just do the dynamic. Okay, so that's pretty simple. However, there's just a little caveat here. The reason why I have the X's is because this is kind of a nonsensical configuration, so I'm just putting it here just to warn you not to do this. Or if you get weird behaviors like why is not working, you'll get an error from LabVIEW, error message. In one case or the other, an error coming out of this function. So for example, here you're saying at the top, do not include static events, but also you haven't wired the user event registration reference, so it has nothing to do. So it's kind of like a no-op, so it's going to give you an error. So remember I mentioned earlier that you need to wire this guy. If you don't have it wired, and this is set the default, which is true, then this will just act automatically on the static. But now you're saying, okay, you were going to act on the static, but now I'm saying don't act on the static, and you're not giving it a dynamic queue to operate on either, so now it's an error. Just to watch out for, because you'll run it and you won't know what's happening. In this case, when it's outside of the static, outside of the event structure, you're giving it a event registration ref num, so it'll operate on that. But then you're saying include the static events. In this scenario, because it's not inside the event structure that contains the static event registrations, it'll actually give an error because it doesn't know what static events you're talking about.
Yeah, the default is really true recurrent event structure plus otherwise.
True. The default if unwired is true inside of an event structure, false outside if you don't have it unwired. Okay. This would be a proper operation, I guess. You have it wired up there, the user event registration, includes static events, false, so it operates on the dynamic, and here it just operates on the dynamic.
Sorry,
Yeah.
quick question. So if you have that in the static event, if you have that in the event case, and you wire the Boolean, or you don't wire the Boolean, so it's defaulted to true, right?
Yeah.
Flush static or whatever, or deal with static. But you also have the dynamic register. Does it just do the dynamic, or does it do both?
It'll do both.
Okay.
Both, also depending on what other inputs you have wired. Because you could have
Of
time,
course.
you could have type, you could have keep the last 5
Of course.
or the last 1.
All right.
So all the other combinations as well. Okay, so here we have we fire the event, and here we're flushing it. So what's happening here is basically you're generating the events just like before, and down here in another loop, we execute a high priority flush, and we're flushing it inside here. Why am I doing it in this sort of convoluted way? Well, because this kind of is how I would sort of develop a system, because I don't really like passing the user event registration outside to another process, but that's just my personal preference. There's nothing wrong with doing that. So basically, I send a high priority event to the event structure that's actually has the queue that I want to flush, and then I say flush it, and then it actually executes a flush state, and it actually flushes the queue there. I could have just as easily done that outside. I could have passed this out to the function, this wire down to the function to do it, but just decided to do it now. And then we also have a stop, which is just a regular stop button. And that just basically shows you that. And if you look at the this thing here, you'll see that I fired the event. You'll see the user event, and it actually shows you some of the data as well, which is kind of useful. And then this queue number 9 had flush button press, and there was a high priority event here to flush, and then all the remaining data was flushed.
Can you repeat what was, okay, you just said all the remaining data, so that's flushing.
So there was a bunch of, so let me just run it with this open, and you can see it here. So if I fire it, look at the top table, you'll see those are the events that are being processed. If I hit flush, it just gets rid of them all. I can run that again.
And that's in that top event structure?
Yeah.
Okay.
This is what the flush happens.
You could have put the other one, if you would have had a brancher.
I could have put the flush in the other, I could have put it right down here actually, but I would have to branch that wire and put it down here just to do the flush. So yeah, you could do both.
Because you would need that dynamic user event in order to flush it, right?
Say again?
You would need that dynamic user event reference in order to flush it, right?
If I wanted to flush the specific dynamic, the user event, yes, I would need that reference to feed it into the flush. This basically is a global flush for that event, all the queues for that event structure. And it's current, static is false. So yeah, all the dynamic events, it's global, there's no filtering going on. But if I wanted to only flush the graph data, I would have to fit in the wire in the user event reference to that flush function to just filter the graph data. And I think I can show that too. If I set this to true, then it's basically the same as the static one. So I generate a bunch of static, and here the event structure is slowly working through them. I can just flush it and run them. So. And I think this event inspector window is pretty powerful because you can see what's going on behind the scenes with all the events and how they're working. So if you have that weird intermittent bug that happens sometimes, then you can just turn this on and monitor and see all the events flying around and figure it out. Okay. edit events, dialog improvements. I couldn't find a cat for this. So. The edit events window is resizable.
Everything should be resizable.
That was wild.
All windows should be resizable.
You can actually, there's a filter box on each of those 2 columns, as you can see there. So that way you can just type in anything you want, and as long as it's in the list, then it'll show you those items based on that, whatever you type them in.
Do better.
And very powerful for if you have tons of front panel controls, and nested ones and clusters and subclusters, and they all show up there, right? So you can use quickly filter them all.
Remember filtering, so I could like check value change in there.
Does it remember filtering? I don't think so. I don't think so. No. I think it starts fresh every time you open it. Okay. Another addition to this dialog is this checkbox and numeric called limit maximum instances of this event in event queue. And here I have an example where I've entered 10. Basically, this is the same as this function, as doing this programmatically, but you're actually doing it on a specific static event. So sometimes this is all you need. You don't need to do fancy programmatic flushing. So if you just have like a slider that's bombarding you, or you don't want it, you can just set it here to a certain value, and that takes care of that. So it's an easy way to get to filter. It basically simulates, I don't know if you guys use queues and notifiers, so it kind of, if you put an instance of 1, it's like a notifier. And like a notifier, you get the last one.
Okay. So you get the last 10 in that example?
Yeah. Okay, so here's I think this is oh, this is the flush. I think I can show this. I'll get back to it at time.
Let's calm down the flow first.
Okay. So this is much simpler. All it has, but it has a slider. And here, if I edit events, I don't have this limit enabled. So if I run it, and the slider, again, there's that delay of processing. But if I set this to 1 instance, run it, then you'll notice that the response is much quicker. Obviously, I'm losing data, right? But when I stop, it stopped. Because it's just giving me the last point. Okay. Okay, VI scripting. I'll quickly go through this. You can actually do a lot more with, there's a bunch, who does scripting here? A few people, okay. They've added a few more methods for VI scripting. So you can actually now create user events, user event cases, and registrations and things like that with scripting. And let's see here. So this is a VI that I borrowed from Norm. Basically, it's, and I'll just open up this guy here. So this to be scripted has nothing, it's just a timeout. And if I run this, I'll put that there, basically you'll see it created all the event frames for those objects. So yeah, you can do that in scripting now, which is new, brand new. So if you have like complex event architectures you want to dynamically create scripting, you can do that.
Can you get the event name that
You
was
get the
not
event-
available before?
Yes.
You can get the event name, yeah.
That's good.
Okay, one last thing. It's a behavior change with something that was, this is important to note because some of you may be relying on this feature or maybe not, but if you're aware of this problem, then this is something that's changed in LabVIEW 2013. And I guess I should, the best way to show this to a demo. Now I want to go over here. Okay, so this is LabVIEW 2012, and this problem or this behavior was this is how it worked in LabVIEW 2012. So if you have, so remember when I showed way back at the beginning of the presentation, we have a user event, but we don't have a case registered for it, and it would say unhandled, right? So here we have a 1 second setting here. So if I probe this. We don't have the awesome user, the event inspector window, so we can't really see it through that, but we have a probe. And when we fire this, if I keep clicking the fire to button, you'll see that the time down there in the probe never changes. So LabVIEW behind the scenes is actually resetting the timeout. Even though there's no case for it, it's still considered it as a handled event, and it resets the timeout. If I stop firing, then it goes to the timeout. So normally what would happen is it would time out in between those clicks. Okay? So if I go back to LabVIEW 2013, and okay, so this guy, it behaves differently. So if I keep clicking the fire to button, you'll see now that the timer doesn't get reset, so you still get the timeouts. This was kind of debated and argued at the CLA summit a few years back, and people considered it as that's the way it is. Other people said, well, it's a bug, and there was some debate. So it turns out that, and I decided to go this direction. And basically, the event still fires, it still gets discarded, but basically the timer doesn't get reset.
Is the timer still reset? You do handle event?
Yeah. That behavior, yeah, if you're handling the event, that doesn't change. That behavior hasn't changed. So
If you don't with that behavior, you could, I guess, keep your own timer on ship register, change it yourself.
Right, that's
Yeah.
what I was thinking, sure.
That's a grumpy cat. That's a real cat. Okay, so, and I just summarized what I just mentioned. Last, no play. Play with events. That's it. And any final questions? No? Okay, thank you.